Hello and welcome. So everything should be fine. We should be live. Um, so yeah, this week I will be working on the killer Sudoku variant. The first part of the stream I kind of expect to be mostly research. Kind of have some ideas, but I want to look around to see if there are some more interesting ways to approach killer Sudokus. And after I kind of collect all the ideas, I will actually try to improve my solver so it can actually handle killer Sudokus. And whenever that is done, if it's this weekend, next weekend, we will see. But once that is done, I will need to improve my UI. Should be a little bit tricky because if I just go to that screen very quickly. So this is not my UI, but this is my UI. So right now, kind of the candidates cover all of the grid. But if I go to the Daily Killer Sudoku website, you can see that, well, obviously, I will need to kind of leave out more space here because well, there needs to be space for the cages to actually describe the killer Sudoku blocks. So that's definitely something I will need to play with a bit, but we are not there yet, and there's plenty of things to do. So let's start with just the basic research. So first of all, if I just open this one, this will actually be quite useful to just use this as an example, basically. So if you are not familiar with killer Sudoku, the normal Sudoku rules still apply. So you still need to have 1 to 9 in every row, column, and every 3x3 block. But aside from that, and you might notice that these puzzles don't have any numbers given, that's because you can actually solve these, and this one in particular is pretty easy. It's just difficulty 2. You can solve these by just, deduction based on the blocks themselves, on the killer blocks. And these kind of have the same rules as normal blocks, as in the numbers within each of these blocks needs to be unique. And the number given in the corner is telling you what the sum is. So, for example, for the 3, well, how do you make a 3? Well, the only possibility is a 1 and a 2. So in this case, you can straight up, put in 1 and a 2. And in this UI, they even give you, all the possible combinations on the side. So this particular UI is actually pretty neat. So this is the first thing. Each of these blocks has only limited set of possible combinations how you can get to that sum. So this is definitely something we can do. And I mean, the moment I do this, then obviously this has implications on the other squares in this block and the column, because these two squares are fully contained within this block and this column. So none of these other squares can have a 1 or a 2. The same for here, none of these can have a 1 or a 2 because those are already claimed here. And you can kind of do that kind of deduction even further. Like you can have a situation where I don't think I will be able to find like a good example. I guess, okay, so let's say somehow we eliminated that this 9 block doesn't have the 2, 3, 4, let's say because like 4 is here. So that means that the 2, 3, 4 is impossible in this block, right? Well, now this block has to have a 1. So that immediately means that none of these squares can have a 1. And that's these kind of rules is something I really want to implement this weekend. So okay, so let's start writing it down. So first of all, the basic rule of the sum. there are only certain combinations of numbers that are possible in this block. Right, and actually this might make it easier to read, well, or not. Okay, never mind. Oh, damn it, this there was a new version release of C-Line and now it's crashing, unfortunately, which is annoying. Right. Okay, so that's the basic rule of the sum, right? Then, as I said, it's kind of the same idea as like block intersection for normal Sudoku. So in a normal Sudoku, let's just go to my solver for a bit. If I have like all the possibilities, okay. Right, okay. So if I have this kind of situation and I know that the one cannot be here, like let's say, right. So it's actually just demonstrated, right? So because I put the ones here, this is already saying, okay, in this case it's a triplet, so that's a bad example. Damn it. Okay, let's just go a little bit back. Let's just put the ones back here, right? And 2, 3, 2, 3, 2, 3, right. Okay, if I have this kind of situation, basically I have eliminated the 1 from these squares in this row. So the 1 is forced to be in one of these 3 squares. The rule of block intersection tells you, okay, but then this block, this 3 by 3, intersects with this row, and this number is fully contained within the intersection. So that means that because this row is kind of pushing the 1 into this intersection, then the 1 cannot be anywhere else in this block. So you can basically eliminate the 1 from here. And you have a very similar thing happening with the killer Sudokus, because if you have a block, the killer block, that's kind of forcing a number into the intersection. So in this case, like this is very obviously forcing the 1 and a 2, right? Into both the column and this 3 by 3. But you can have more subtle situations than this, like obvious 1, 2. Then obviously we can just remove the 1, 2 from all of these places, right? So we can kind of reuse this kind of logic. So that's let's call it the rule of the intersection. So this one will be if a killer block forces a number into another block, then we can safely remove the number from the rest of the block. Okay. Why is my wrapping not working? Wrap. Soft wrap. No, okay. That's view. Active. Okay, soft wrap. Okay. Right, and I guess now if I do this, unless it crashes, okay, now it actually does wrap it fine. Okay, so it's the rule of the intersection. And we actually have the same thing the other way around, right? Like if if a killer block is in a square, but I guess we don't really have to write that down. So I was thinking about the situation where we have a killer block in a square that already has the number somewhere else, but that just gets eliminated by normal Sudoku. Yeah. So that's fine. That's not an extra thing. The reason why this is special is because this can happen in the situation that I described here. Like if I put a 4 here, then this 9 sum cannot have the 2, 3, 4 as a possibility, and suddenly it forces a 1 to be somewhere in one of these 3 squares. And that's different from normal Sudoku because we still have no idea if this is 1 to 6 or 1, 3, 5. We just know that a 1 has to be in one of these 3 squares. Right. Then the next thing, this is a very big thing, and this will be super hard to implement. So one thing to kind of realize in Sudoku is that if you take any block, so it can be a row, a column, or a 3x3, the sum of the numbers in that block is always 45, because that's just what you get if you sum 1 to 9. And each of the blocks, has to have numbers 1 to 9. But with killer Sudokus, you can kind of use that. So if I just highlight this, and this UI actually does give you, a very nice hint what is the combined sum. So in this case, the things I highlighted are together 44, because that's 12 plus 14 plus 18. Well, since this block has to be 45, well then obviously this is the 1 straight up, it can be nothing else. So that's the rule of the 45. Each Sudoku block sums up to 45. So, okay, how will we use this? I'm kind of thinking so this one was a very easy example, right? But you can also have this kind of example, right? That summing these up is 25, which means that these have to be 20 together. So I guess we should just create a new sum block essentially for these 3 squares. And these are if you have, okay, let's go back to this. So a little bit of naming. These are usually referred to as killer blocks, and then if you just have a block that doesn't have the restriction that the numbers don't have to be unique, although in this case they have to be, right? Because they are in the same 3x3 square. So in this case we could actually create a proper killer block here. But in general, if you just have a clue that says this square and this square and I don't know, this square together are this much, that's referred to as small killer. So we can create a new small killer block, and alternatively, if the block is fully contained within a Sudoku block, so a row, column, or a 3x3, we can make it a killer block. Right. So it's like, here is another example, right? Like we have these numbers together, they make 34. So I'm missing 11. So these two need to sum up to 11. And you can have situations where right now I'm not really... Okay, so there is one. Okay, so if I highlight, oops. Okay, so if I highlight this, you might notice that the 15 here is kind of overhanging out of this, you know, free column section, right? So because we have already deduced this one, we can actually exactly deduce what this is, right? So let me just actually select it so it actually gives us the sum. So these three things together is 110. And we know that if we take 3 different blocks, it will be 135. Because each is 45, so, you know, 2 of them is 90, and then 3 of them is 135. So it leaves us with 25 remaining, right? We know that this is 14. So that leaves us with, I said 25, right? So that leaves us with 11 remaining. So we know this is 11, these two squares. Which means that this has to be a 4. So, okay, so how can we formulate this in like a more... So this is kind of an overhang, right? So for the situations, or I guess what I could do, if I just create, I don't really have to do the deduction into the 4 because that would actually happen naturally. What I can do though is just basically create a new block for these two squares. And the same would happen here, like I could create a new block for these two squares. Right. And I guess in this particular Sudoku, we don't really have a situation where like the new block would be across multiple... Yeah, not really. But I mean, if I go back to the... and just open like a more difficult 10 out of 10, sure. Yeah, like for example here, like this is completely useless. Like the 45 is like 0 information. But okay, let's... is there... Okay, so this 16 actually, for example, right? So... can I deduce something? I mean, I can deduce the sum of these two because I know the rest of in here, and yeah, the same kind of happens here. I wonder... Yeah, so there would be like a sum of these. It's interesting, like so far it always ends up being contained within one block, and I'm not convinced that this is the rule, because I'm actually pretty confident it isn't. But so far it just somehow ends up being that like these 4 would be contained within this row, so we know for sure these are still unique. I guess actually I just realized I highlighted it wrong because we only know these actually. Okay. Yeah, so the sum would be over all of these. Oh, but it's actually interesting because... Oh, then we kind of have the inverse, right? Okay. Well, if we know the sum of this, right? Like then obviously I know what is this square, because it's just the remainder. So I wonder if I basically I'm not like I'm trying to think what would be the programmatic way of generating these. Because I mean, like when I'm highlighting it manually, it's all kind of obvious, but what would be the algorithm for doing this? And we really want to look across like many squares potentially, because you can kind of find like one single place in the puzzle that it actually starts making sense. Within one square, it's very easy. I can always just look at what are the blocks, killer blocks that are fully contained here, and basically just create the inverse sum for the rest, right? But that's almost kind of pointless. Yeah, like for the top row, for example, it will be very useless because it's just like the only thing that's contained there is the 9. And I mean, we definitely can see, like for example here, like there's nothing, right? Like nothing is fully contained within this row. Okay. I wonder if it's completely useless to do that then. Because, like, if I have... I'm pretty sure if I just have one killer block, it's useless, because it doesn't really add me any extra information. I think it's not useless the moment I have more than one thing. Because if I don't... I almost basically kind of want to capture this sum explicitly, right? Like this sum is kind of captured implicitly. But unless I kind of create this kind of block manually, like there will be nothing creating the correlation between these 3 blocks. Interesting. Okay, so we have the route of the sum. There are, yeah, sure, we know that there's only certain combinations that make the sum, so that means only certain numbers can appear there. Rule of intersection: if a killer block forces a number into another block, yes, indeed, that's obvious. And the rule of the 45, but the rule of the 45 we still haven't exactly expressed. I'm trying to think, like, would it actually make sense? Does it make more sense to create the sum over these 2 squares or the sum over these squares? I mean, this is adding new information that I didn't have before. I kind of have this information implicitly, that this is a thing. So how... I mean, it's almost... Yeah, it's almost like we should basically take... Go through every block, then go through every 2 adjacent blocks, every 3 adjacent blocks, and so on. Because I guess only that way we kind of explore all the possibilities. Otherwise, we will always be missing something somewhere. Huh. Okay. But I guess this still doesn't really... So if I take this, right? Okay, so this would basically tell me that... Yeah, if I do that, this is 72, right? And I know that I need to get to 90. So... So this is 18. So I would basically insert a new 18 block over here. And is that actually enough to force the 4 over here? Well, what would be the rule for that? Is it like if it's... This is tricky. Because then I basically need to have some sort of rule that says, like, if I have 2 things overlapping over each other, that somehow should force the remainder into the rest. Okay, so how would the rule... So if I would just straight up have a rule that says if one block is contained within another, and I don't have like a sum block for the other part, I should just do that. Right, okay, I guess, so that actually isn't a bad rule. Right, okay, so if I figure out that this is 18, right? So I would have a new block over here. Then basically I have a thing that goes over all the killer blocks. And then when it runs across the 22, it goes, oh, hey, 22, like you have a block that's overlaying you completely. But you don't have a sum block that's describing this square. And I mean, for one square, it's obviously just a specific number. But again, like there can be situations where it's like, okay, like I know what's the sum of these 2 numbers, for example, somehow. I mean, in this case, I actually almost know that, because if you look at this is a given sum, and I kind of know the sum of these 2 things, right? So that's almost the situation, but like imagine that I somehow figured out the sum of these 2 numbers, then I can just go and say, oh, okay, the complement is the complement. And actually at that point I can get rid of this thing completely. Right, okay, no, that's nice, that's pretty good from performance perspective. So I can basically go and say, okay, like you have another killer block contained within you. Oh, that's such a wonderful idea. I love it. Okay, I love this. So what I can literally do, I can have a pre-computed, basically all the sums, right? I can have these 2 rows, basically have like this overlaying grid of sums. and that's my like starting setup for each killer puzzle, right? So it will be quite a lot of blocks, but it should be okay, right? And because I have that, then the rule basically is, hey, if at any point you see that like a block that I have contains another block, so for example, you know, in this situation, right, there's actually quite a few of them, right? Like there's like this 11, there's this is fully contained within these 3 rows, this, right? Like all of these are fully contained within these 3 rows, right? So then I would just go and say, okay, so that's the situation. So let's just get rid of this, you know, big thing that sums up to 135 because it's 3 different rows that each of them is 45. And instead of having this big thing, let's just create the complement, which will be, you know, these squares. And obviously all of these are already specific blocks. So you would basically like iteratively delete the starting sets. And this kind of continues like the moment I figure out that, okay, like, you know, this is supposed to be, I don't know, 14. Well, then I can get rid of the 26 and just say this is, you know, 12 and this is 14, done. And instead of the one large block, I suddenly have 2 smaller blocks. Oh, I like this very much. Like it's still kind of, it's still, I don't want to get too far from like how humans solve these puzzles. So this is still kind of adjacent-ish, right? Because the human logic is kind of like that, like you go, oh, okay, like I kind of know what these 2 together are and whatnot. Although to be fair, like humans wouldn't really go that deep. Like humans would usually just like look for the singular squares, right? Like for example, as I shown like here in this thing, since I know what's the sum in here, in this row, the row is 45 minus 11, so then I know the sum of these numbers. But if I know the sum of these numbers and this 11, then obviously I know what this number is. So this is kind of what humans would do, but I think just like this kind of splitting of the blocks is very close to that. Okay, and I think that's actually a very powerful rule, because since we keep dividing things, like there will always be situations where like one singular cell just like pops out, and then we can just have a very simple like enforcing rule that just says like, oh, if you have a block of size 1, then obviously, you know, you are done. Okay. No, I like that quite a lot. Right, okay, let's write it down. So, okay, where is it? So this is basically already a solving technique, right? So we are saying that if no, so we start with a puzzle that's pre-filled with all the combinations of Sudoku blocks, of adjacent Sudoku blocks, right? So this is rows, columns, and 3 by 3. And their sums. And the rule is, if there is a block fully contained within another one, remove contained, fully contained, remove the block, well, remove the outer block and insert the complement. Okay. I kind of suspect that this is actually way too powerful. Because I think this will consider like crazy massive combinations. So maybe we need to limit it a little bit. Like essentially the weaker version would just be, we don't do the combinations, we just look for like every single block, right? So in this case right here, so in this row nothing would happen, so this would remain like this is just a sum of 45, right? Because there's like nothing to complement with. But if I look basically at this one, like there's this 12, so I would delete the 45, which represents this column, and just insert, you know, this, which is 33. And I guess immediately, well, not immediately, because this one yeah. Damn it, but this one is way too big on the other hand. It's I kind of need to consider like multiple blocks. How can we get closer to what humans do with the puzzles? But I mean, at least we have some basis. But it would be kind of neat if we could somehow detect this situation where there's like one square that's like left over. I could technically detect that. So okay, so if I take these two rows and basically take all the killer blocks that intersect with these two, I can kind of detect that I have the one overhanging square by just counting the number of squares, because this is, you know, this is 19 squares and this is 18 squares. So maybe I could use that to detect the situation, and it goes both ways, right? Like it could be also the where the heck is it? Do I have the don't really have the one square situation here, I don't think. I mean the inverse situation. It was in the previous puzzle, I think, right? In this one. In this one. Right. Okay, so basically if I know that this is 8 squares, the block is 9 squares, well then obviously that's 1 square difference. Oh, but this is trickier to notice because I cannot be looking at... So in this case I would be looking at the killer blocks that are fully contained. Right, okay. So if I... Okay, so these seem to be weaker versions of the previous very powerful rule, I guess. So this could be basically these two things. Okay, let me write it down. So looking at any combination of adjacent blocks, if the number of squares within this block is within this area, I guess, because we are looking at bunch of blocks, right? So if the number of squares within this area is 1 less than the number of squares contained within the killer blocks that intersect with this area, then we know the single remaining square value, right? So again, this is the situation. Is it in this puzzle as well somewhere? Let me just quickly check. I'm looking around. I don't really see it. Yeah, okay, I see one. Okay, so basically this... damn it, this one has 2, but I mean, you get the point, right? If this wasn't the thing, if it was just like this, because I don't think there's this situation over here. So yeah, then I would immediately know the value of this square. I wonder, is that actually complementary to the other rule? So the other rule is, if I take this kind of area again, oops, so if I take this area, it's 9 squares, and the killer blocks that are fully contained within that area, not intersecting, not just intersecting but fully contained, if their area is 1 less than the block, then we know the value of the square. So that's the kind of the opposite thing. They do sound complementary to me, but I'm not 100% sure. So if the number of squares within this area is 1 more than the number of squares contained within the killer blocks fully contained within this area. There's way too many times saying contained, but I guess I cannot really write it in a better way. Then we know the single remaining square value. Okay. Yeah, so these two rules are way closer to human logic. So I think I should also implement the general one, but probably most puzzles should be solvable with just this, I think. Because I mean, the thing to kind of consider is that when you have killer Sudokus, because of like the overlaying of information, it's kind of harder to visualize things than in like a normal Sudoku, because you keep basically working with like these sets of numbers, right? So I actually don't have like a great gauge on how difficult these are, you know, compared to normal puzzles. Yeah. It's yeah, okay. I think these two things together, or I mean, okay, so these are the logical steps. Then we also have the thing that I said here, right? Like you have the only certain combinations are possible, and the moment I know that like a particular killer doesn't have a 1 in it, well then obviously I can just eliminate all the combinations that have 1 in them, which is pretty straightforward. And the rule of the intersection, that one remains. So yeah, like if a killer block, for example, forces a 1, then obviously the rest of the block cannot have it. What's happening? Why do things keep disappearing? That's weird. Okay. So yeah, these two are always there. And this what I was doing now was basically like expansion on the row 45. Okay. So I think we always do these two. Then we should try just doing this one, and then if that fails, kind of start with doing this one. Like this really I think should be like kind of the last resort of the solving. And it's kind of like from the performance perspective, this is annoying because I guess I would have to kind of always start with, you know, these like prepared, like all the possible combinations of the blocks. And I guess these don't even have to be adjacent, right? Like you can have a situation where probably not in this puzzle because this is too easy, but in this puzzle again, right? Like if I would be looking at these two, maybe that's nonsense. It kind of makes sense for, right, like in this case, this squiggly shape kind of, it's across multiple blocks, but if I kind of draw it this way, you know, it could tell me something about these two squares, or like split it in a different interesting way, I don't know. Yeah, so maybe it's not even adjacent, right? It could even be something like this, right? But then the problem is oh crap, okay. I just realized another thing. So clearly this will not sum up to 90 because it's sharing this square over here. But if you know something about, you know, these tentacles, let's call it tentacles, going, you know, to the sides, well, then maybe the center, you can say something about the center, right? Because what this is 90 minus, like the sum of this is 90 minus the center, right? Because that one is counted twice in the, I guess, would be counted twice in the 90. Ooh, okay. And yes, that gets even more interesting because now if you do this, now we know what the intersection is, right? So we know that this is 135 minus 15. Oh geez, this is horrible. What did I think of this? Yeah. Yeah, this might be also quite powerful. But this is like nightmarish. I would sincerely hope that like no humans use this kind of technique, but I'm sure someone does. Okay. Yeah, this intersection could be super interesting. But the good thing is like they cease to be interesting the moment you kind of have way too many, right? Like if I do this, well then it kind of devolves into just like a bunch of squares. Okay. Well, let's just write it down, but I really don't want to do anything with this as of right now. But let's just write it down as an observation. Okay, I guess observations. So, if we have an intersection of blocks and we know the sum in the intersection, then we can talk about the remainder and vice versa, right? Like either we can deduce the intersection from the surrounding stuff, or we can but I guess that would already be obvious. So if we have like basically, right, so if I was doing this kind of stuff, right, so either this 15 tells us some information about the surrounding stuff, but I guess if the intersection can be deduced, that was already possible, right? Because I'm kind of yeah I think it should be the case, because like if I can deduce the value of this from the sum of these things, then obviously it can be also deduced from like one of these things. I think. Because just adding more stuff just doesn't narrow it down more. Maybe it does. Yeah, I think it's just interesting the other way around, where like the sum can become interesting because of the intersections. Because yes, like if you have this kind of overhang, like you could kind of do oops. Like it will not really work here, but you could do something like this, and or maybe this is complete nonsense, because in the situations that this would add information, I already need to know what this is, which means I kind of know what this is, which maybe, yeah, okay, not sure about this one still makes me confused. Right. I've been streaming for an hour, so I think it's time for a short break, and after the break I will actually start coding finally, because so far it has just been thinking about weird puzzles, and it's time to start writing some code. Okay then, see you in 5 minutes. Okay, and I'm back. Right. So, as I said, time to actually start writing some code. So we have these nodes. Right. Okay. So we will definitely need some sort of killer block checker. So let's do that. Let's just call it killer block checker. Right. Okay, so and from the things we talked about, what do we actually need here? So we will need definitely a size, which will be the number of blocks. Inside. I'm wondering, I don't think we really need anything special for like the block intersections, because we already do that with normal blocks, and it's just that prepositions. Okay, solve intersection. Yes, so we will need the solve intersection. Okay, and actually we will want to have it work either way. Yes, so basically we will want to have an intersection from a normal block to a killer and vice versa. And I guess just for convenience sake, I think having an intersection of a killer with a killer might be a good idea. I'm a little bit iffy on that idea, but I mean, okay, so this is our namespace Sudoku. Oh, my formatting is all over the place again, damn it. It's definitely not following this format. Yeah, okay. Okay, let's try to fix that if I can. Wait a second, do I have a... I don't have a clang format, do I? No, I don't. So... Yeah, it's a bit slight issue with the formatting. I'm not quite sure what broke, but yeah. Okay, so we definitely want this. We definitely... Oh, wait a second, now I think it's... Try to do the... No? No, that's also wrong. Damn. Okay, whatever. Let's just continue. And then we will need to introduce the other way around on the block checker. Right, so this is the intersection. Then and I was saying basically what we kind of want to have an area or something like that. Basically something I can use over here. So looking at any combination of adjacent blocks, right? If the number of squares, basically these two ifs, I kind of need to be able to represent a combination of adjacent blocks somehow. Yeah, I kind of think I want to have another class which will be just some area, I guess. And I guess no, okay. Right. No, back. Yes, under creation. So this should be called small killer block checker, because in actuality this will also work for small killer rules, which I haven't shown yet. I will try to look them up if I can find some. So let's just quickly jump to this. No, this one didn't have them. Small killer. Right. So yeah, just to give you an idea, it's something like this. So basically this is saying these two squares sum to 13, these three squares sum to 15, and then these four squares sum to 31. But it doesn't make any like restrictions on the uniqueness of the numbers, which also works for like multiple rows or columns, because obviously then you have multiple of a number, because each row and each column will contain, you know, odd numbers. So yeah, so the small killer. Okay. So then what we said, class Sudoku, not class, namespace. Wait, is it actually, did I make it big letters or small letters? I don't remember. Oh, it's small letters, okay. So then I did it wrong here. Okay. Okay, so, and as I said, the things I want to do is, if I basically have one square overhang or underhang, how would I do that? I guess I just need to get at the squares here, like there isn't really... I don't really see anything super useful. To just straight up implement here. Because I guess in the solver, so in the solver we want to get the killer blocks that are fully contained within the small killer block checker, or that intersect with it. Yeah. So I guess that's almost, this should be on the Sudoku, right? So basically over here I kind of want to get std vector killer block checker. Hey, welcome to the stream. I'm pretty good. How are you? Yeah, so on the Sudoku puzzle itself, we want to have a thing that returns the killer block checkers. This will be get fully contained, and this will be based on a small killer block. And another one which will be get intersecting. I'm working on a Sudoku Solver, so this session is adding support for killer Sudokus. And if you don't know what killer Sudokus are, so these are small killer Sudoku rules. They basically give you the sum of some squares in the puzzle, but don't make any assumptions about like repeating numbers. So for example, this 31, it has these 4 squares, but you know, it could be like this can be a 9, this can be a 9, and these two obviously need to be different because they're within the 3x3 block, but it's kind of the idea. And then you have the proper killer blocks that kind of tell you the sum of the squares, but these actually need to be all unique. So even in this 26, all of the numbers within this block need to be unique. So then you have these puzzles that don't have any given digits at the beginning, but you know, you need to figure out things as you go, basically. Hey, welcome. Right, so this will get killer blocks that are fully contained within, no, this is C++. Contained within the small killer block. So it's not fully contained, and I cannot spell fully contained blocks. And this is the block to look for, yeah, I guess like that. And this one is very similar, except this is just intersecting. Those are files, and .h is a header file, and .cpp is a cpp file, which is kind of, I guess Python doesn't really have that, right? So headers is kind of, they declare stuff, and cpp is just the implementation. I'm trying to think what's... Yeah, this is pretty unique C and C++ thing, headers and CPP files, because they work in a pretty weird way. Like, it's kind of a historical thing mostly, honestly. We should be getting something much better soon. And they're intersecting. With the small killer block. Right, I definitely want this header. That's kind of funny. I consider Python pretty hard, because in general for me, like, scripted languages are super hard to write correct code in. Why is this not getting recognized? Yeah, checker. Right. Okay. Right, so these two functions, I guess methods, will give us the list of the contained or intersecting killer blocks. So then the solver can use it to figure out if... Oh, I guess I will also need... I also need kind of a way to create a list of squares that are basically contained within these. I mean, for now, I guess we can just work with the assumption that these don't intersect. And that should be fine for a while at least. But in the future they definitely can potentially intersect, especially, well, as long as I don't create any fake ones in the puzzle by solving it, then it's fine. But the moment I start creating killer blocks, like, either I would have to be super careful about how I create them. So if I kind of do the logic that I described previously, as in like doing the complements, so if I create this block, then I just delete the 26 and create also this thing, then I don't have a problem, because since nothing is intersecting at the beginning, nothing is intersecting even later, so that's fine. But if I start doing, like, for example, over here, right? So again, I know that this sums up to 38. I know that the 3x3 block has to be 45, so I'm missing 7. So I could potentially create a block for these two squares that's just 7 sum. And at that point I have intersecting blocks, because this kind of, you know, goes over two different blocks. So yeah, for now I don't have to overcomplicate it, but in the future I will need to have some sort of utility that takes basically this and just like gives me the list of unique squares or something like that. Okay, so what else? Right, I said looking at any combination of adjacent blocks. So then I guess on the Sudoku puzzle I will want to have something like the pre-computed areas or something like that. I'm wondering how to do it efficiently. So, okay. So basically what we have inside of the puzzle is just a bunch of squares, right? Now, if I pre-compute all the shapes that basically gets generated if I just start doing, you know, like these two rows together and then, I don't know, these two rows together and so on. I still need to translate that to actual, like, pointers pointing to these specific squares, which is like, those are unique to each specific puzzle instance. So even though if I have the shape pre-computed, I still kind of need to go and change the shape into actual pointers that point to the correct squares in the puzzle. Cool, thanks for the sub. And there should be alerts, but maybe they're broken again. Yeah, sorry. Sorry if they are. Yeah, sometimes these things don't really work well, unfortunately. Or maybe there will be one in like 5 minutes. That already happened once. So we will see. Right. Okay, so how the heck would I do this? Okay, let's assume I have the pre-computed shapes, right? So then basically in the constructor I would translate those shapes into pointers to squares. Not really. I mean, I do plan to have a look at like the Unreal Engine at some point, but for now, okay, I can actually show you. So, well, okay, this is not super exciting, but this is the thing I did as far as interfaces go. You know, you have a Sudoku puzzle, you can put in numbers, you can press solve and it does solve it, and that's kind of where I am right now. Not exceedingly impressive. However, this is all done in C++, even though it's, you know, running in the browser, which is kind of the technologically interesting part, not necessarily impressive in any way, but yeah. Oh yeah, and if you want to play with it, like all this code is online. Should be linked in the description, I hope. And also this is also online. If you go to yeah, it's being served by GitHub basically, so it should be all linked through the description of this video. And if you can't find it, let me know, because then I need to fix the description. Right. I mean, making games is hard, and usually making games has very little to do with coding, so yeah. So I kind of think I should have over here small killer block checker. Something like this. So this will get initialized in the constructor, and this will be all the small killer block checkers that we basically have. And I guess I can just start, it's simple, I can just start with just having the rows, columns, and the 3x3 blocks over here, and just set them to 45. Very straightforward way. And then in the future I can basically pre-fill it with more stuff. Yeah, I kind of like that idea, so let's do that. So then on the small killer block checker, what I need is well, the constructor will basically initializing from not like that, right? It's just a square. A square, right? Okay. Yeah, and there's a guy that made a complete game out of it, first-person shooter. He's a designer that just took the Unreal Engine and just basically coded everything in the Visual Script. So yeah, okay, I think I need to initialize with the sum and the squares, and I'm taking the squares by value because I mean I will need to store those anyway, so I can straight up just do that. Right, so over here sum, so basically over here I can just do sum is sum and squares are squares. Well, std move squares. Ah, thanks for the follow. So Twitch notifications are actually working. Okay, that's good to know, but YouTube is somehow broken. Okay. Cool. Yeah, no. Sorry. I keep struggling with technical issues all the time. It's kind of crazy. Like, nothing works properly. Yeah, cool. Well, you know, you did the right thing. You came to the to the stream that's actually working and has notifications and stuff. And I also think like on YouTube, the delay is kind of crazy. Especially if you have like recoding. My PC specs? My PC is pretty beastly, but yeah, this is not really related to the PC speed, unfortunately. Why is this? No, this should be fine. Well, I don't know why it's complaining. Okay. This will definitely have some sort of propagations that I will need to implement. But I'm not quite sure what will those be yet. So let's just do nothing for now here. Can't fully contains. Right. So I guess now I can implement this thing. Okay, but before that I actually need to have the std vector error block checkers, right? Yeah, I think YouTube is good because, so on Twitch, by the way, I did downgrade my video quality significantly for this stream. But on Twitch you don't get recoding unless you are like partner, I think. So, but on YouTube you get it like for every stream. You always get like, you can look at, you know, different versions of the stream. But the problem is, if you're actually watching like on mobile, I have had situations where like there was a delay that was several minutes, and that's kind of crazy. Like someone asked a question and it was obvious that like that was a thing that happened like 2 minutes ago. But I mean, at least people can watch, which is good, but it's kind of crazy. Okay. So okay, this will be it's a bit tricky to implement. So I guess we want to go over each killer block and verify if it's fully contained. What do you mean 0 to 1 coding stream? Okay, so for go over all the killer blocks. And here we need to figure out if it's fully contained, right? So I guess there should be a method over here. So do is fully contained, and I guess this should just take a vector of squares, because that kind of makes sense. Oof, that's a hard question. Which way? Well, I kind of learned coding over a long time, so plenty of places, I guess, is the answer. Honestly, the best way to learn coding is just practice, which, you know, it's not a super satisfying answer, but honestly it's true. Like, just, you know, code a lot, and that's how you kind of learn coding. And I guess I want the same thing for is intersecting. Okay. Right, and this will be pretty straightforward. So, okay, not like that. I definitely want to just have it in namespace. What am I doing? Right. So, over here, yeah, I just want to go over all the squares. And check if this square is contained within the small killer block. So this will be a second loop. Over, what did I call it? Oh yeah, over the squares inside of this block. And if, oh yeah, yeah, I mean, books are good, but Like, it's good to have a good start, but other than that, like, once you start being able to code something, like, it's way more interesting to just, you know, code stuff and learn from that. Right, so found false if right, actually, let's just make it very explicit. So this should be a const square pointer, the same as this one, const square pointer, and this is the same square. Then found is true, and if we haven't found it, if not found, then we just return false, and otherwise at the very end we just return true. Right. Okay, so we go over all the squares in this thing and we try to find them. If we don't find one of the squares, then obviously it's not fully contained, so we return false. Otherwise, at the very end, we just return true, and that's it. Okay. The intersecting will be similar, so okay, the if statements will be slightly different. So we go over all the squares. Now, if we have found a square, we know it's already intersecting, so here we actually want to return true. And otherwise, if we don't find, basically if we don't find any intersecting square at all, then we return false. Okay. Right. So we have these two. Over here. Right, okay, then now I can write these functions, so oops. Right, get fully contained. Right, so we go over the killer blocks, and if block, the other way around. So if how to make an infinity loop like a portal in a game? Well, what do you mean by that exactly? Block. Why is this not? Is fully contained. Right. I need to get squares or something like that over here on the killer block. S3 vector square get squares. Right. Yes, and I also need the square header, of course. I mean, that would kind of depend on what kind of game you are doing exactly. Okay, I guess for the normal killer I want exactly the same constructor as for the small killer. Yeah, so I just want to sum and vector of squares. Right. Yeah, I mean, so in that case I suspect it will be very specific to Unity. And I'm sure if you search for like Portal Unity, there will be something. I would be surprised if there wasn't. Squares. Okay. So then obviously size is very easy, so size will be just squares dot size. Okay. Over here, so the get squares now should work. Why is this complaining? Ah, okay, this definitely should be const. Yes, that's true. No, this is Sea Lion. So this is from the IntelliJ family of IDEs. For C++, this is very nice. And I think it's also cheaper than Visual Studio. But don't quote me on that because I could be actually wrong. I don't remember. But you can definitely use this for free if you are developing on a open source. Well, the Visual Studio Code is free. The Visual Studio itself isn't, or maybe the compiler isn't. I don't remember exactly what the thing there was. But yes, Visual Studio Code is for free, but then you need a compiler, and Visual Studio Code isn't quite as good as Sea Lion. Right. So is this now happy? Yes, it is. Okay. So if the block is fully contained, then yeah, let's just check it into the result. So result and place. Well, I guess this actually doesn't matter in this case. And just a pointer to this block. Visual Studio is free? Okay, then I guess I'm out of touch with what the current licensing is. But I'm pretty sure is also the Visual Studio compiler for free, because I think that was the problem, that like you couldn't really use it for C++. But yeah, again, it has been a while since I checked, so things might have changed. Right, and get intersecting will be the same idea. Is intersecting. Right. Okay. Right, I definitely need to have an accessor for the sum. In both of these. Oops. So one over here and one over here. Should be a const. Okay, interesting. Yeah, then maybe something changed. Because it wasn't a long time ago where basically you could only use Visual Studio Code, and that one you had to use with, like, you know, the Cygwin or compiling using GCC through WSL and things like that. You couldn't really use it directly. But yeah, again, like, things might have changed. What is this complaining about? Unlikely. I don't really do C#. I'm mainly a Linux developer, so I'm kind of skewed towards that kind of set of languages. There's a lot of people already doing Python. I am doing C++. I mean, this is a C++ project. Or what kind of series would you like to see? Okay. I guess I want to have a size here as well. I mean, if you are learning Python, there's so many people doing Python, like both on Twitch and on YouTube. It's crazy. Like, it would be crazy for me to just, like, join the crowd because there's already so many people. Not that many people doing C++. There's quite a few people doing Rust, for example. But yeah. But again, this is C++. Right. So I have the get fully contained. I have the get intersecting. Solve intersection. Yeah, I'm not super fond of Java. I had to code in it a bit, but it's definitely a language I deliberately avoid whenever I can. Okay, I need to implement these two things. But I already did that for the block checker, didn't I? Solve intersection, yes, indeed. Yes, basically, I found basically this exact code just slightly changed. Yes, C++ C++ is case sensitive. For file names, that depends on your file system, but inside of the code, yes, it is case sensitive. But there are also different styles, so you don't have to use camel case. People still use like underscores. And I mean, right now I'm using a style where basically methods and types are camel case, but variables are underscored. This is the, what do you call it, the snake case? Yeah, something like that, I think. Right. Okay, so let's take this thing over here. Okay. So right. Okay. I actually don't know that one. Huh. Looks interesting. Okay. Oh yes, I don't have another set over here. The name should be in the top right corner. Hopefully you can read that. Yeah, I think it should be readable, although I have a horrible font, I'm just realizing. What is it? Well, it should be everywhere, I hope. So it's called 95 Another Castle. Or no, wait. It's the song is called G. The artist is Cederblad and Book, and 95 dash Another Castle is the, what do you call it? The album. Yeah, so great names. Okay. So instead of LM, right, so we go across all the squares. Right, but now I need access to the block checker. Okay. So I think I will need to make this class a friend of block checker. I don't think there's any way around that. Okay. Now this should work. No? Right. I actually need to include this thing. Yep. Now it should, yeah, okay, now it resolves, perfect. Right, okay, so I go over, create the intersection. Then for the squares, overall the numbers, intersection, okay, I guess this should work as it is then. I mean, that's not too early. It's great to start early. I started pretty late. But, you know, at that point that was still considered early. Now things are definitely changing, like coding is way more pervasive. Yeah, then, you know, you still have all the future ahead of you. That's great. Just, you know, stick with it. That's the main thing. Just keep trying. And especially these days, like, there's so many great channels on YouTube that do like amazing series explaining things. Like for me, this is just a hobby. Like, you know, over the weekend working on a hobby project. But there's a bunch of people that just are doing YouTube as full-time, and some of those are doing coding and stuff. Okay, let's keep continuing. Well, thanks. Okay. So this should be working, I hope. I will need the same thing for the... Let's just remove this for now, because I don't think... Well, there's a lot of people that are getting way more viewers than me, so, you know, that should tell you something how amazing I am. But thanks. Right. Okay, so this should be fine for now. This also should be fine for now. I wonder if I'm actually ready to start playing with the puzzles then. Because I think all these things are kind of written. Okay. So how do I do this? Well, several options, right? So I could, yeah, I could just finish implementing this. Yeah, I mean, you're right, but to be fair, I'm not doing this for viewers or anything. It's just, you know, my hobby project, and me streaming is kind of forcing myself into a regular schedule, so I just do it every weekend, the same time. It's recorded every time, so if people want to watch it and enjoy it, then great, but the main thing is, like, I'm trying to force myself to just stick with it. Okay. So what I could do now, I could actually come back to the UI and implement the killer Sudoku over here. the benefit of that would be it would make it much easier to like play with the puzzles, because I could just like input the puzzle once, and since I already have this storage that the puzzle is solved in the URL, well then it's very easy to just like keep reusing it. I don't have to keep like re-entering things. Alternatively, I can kind of do the same thing in code, like in my main, but maybe that's a good idea for now. Right. Okay, but before I do that, I really need a short break. So 5-minute break, and see you then. Okay, and I'm back. So what's the next step? How do I actually want to represent the Sudoku puzzle? I guess like one way to represent these cages is just by the coordinates. Yeah, so it could be just like the sum and the list of coordinates where the cage is, right? I guess that's actually fine, because then I translate the coordinates into pointers to squares. It would be a little bit awkward to actually draw in the UI then, but it's not a huge deal. Yeah, okay. So let's just right, basically over here. So apart from the basic constructor, I guess it can still be the same constructor. Okay. Yeah, right, over here I kind of need a representation. So okay, it can be struct circular cage. So this will be, and I don't need a small killer cage as well, right? So this will be the sum, and then std vector of pairs, unsigned, unsigned. So just two coordinates, just a list of those, and this will be the coordinates, right? Then the same over here for the small killer cage. And then I guess I just take them as the parameters. So killer cage. I might do a C++ series at some point. And yeah, have a nice day. See you. So killer, and this will be just an empty vector by default. And the same idea for the small killer. Yeah, and I guess then I can create like specialized constructors if I'm like, it will be it can be a little bit awkward to basically create a size 9 basic Sudoku puzzle that is using small killer cages, because then I need to kind of, you know, specify all of those. So I might create like more specific constructors, but I guess for now this is fine. Right, oops. And where do I actually have the constructor implemented? It should be, oh, here it is, right. Right. Okay. So these I need to store. Kiloblocks I already have. And yeah, okay, so these okay, so this is a separate thing though. So I also want this again for the small killer blocks, right? So if I basically have a puzzle that has okay, I need to find it again. Small killer Sudoku, alright. Okay, so if I have this kind of puzzle, okay, then the blocks basically would be, you know, in this case, right. So these 3 squares is the 20, 1, 2, 3, 4, 5 squares is the 22, 1, 2, 3, 4, 5, 6, 7 is the 20. These 2 are 15, 13, and so on, right? So those would be the blocks. So these are the things I want to initialize. So but right, I want to do that in the setup checkers. Killer, small killer. Okay, setup checkers. Right. Can just copy paste this. I don't think I need this over here, because I mean this will always get set to something based on whatever the constructor got, so this is fine, but I do need to change it in the header as well. Setup right over here. Yeah, I really don't need this. Okay, cool. So this should be, yeah, now it's fine. So okay, so we go over, we set up basically all the squares, and then basically down here I need to now set up the blocks. Okay, right, so this would be killer blocks. Right. What kind of constructor did I give it? I've already forgotten. So it takes the sum and the vector of square pointers. Okay. So that's pretty straightforward. So basically what I want to do in here is I want to loop over this. Okay. So for each of the killer cages, we will need a vector of square pointers. And right, so this will be, I need to loop over all the coordinates. So this is k dot coords, right? And from data I dot first times size plus I dot second, right? So this is the specific square. I want to take the pointer to this and push it into squares. Okay, push back, right? Okay, perfect. So this will go with the coordinates, push back this thing, and over here I want to do killer blocks and place back with the sum, which is k dot sum, and now I have the squares, so squares, right? And actually std move this because I don't want to copy it. Okay, so this setups my killer squares and exactly the same thing, I mean killer blocks. So exactly the same idea for the small killer. Oh, what the heck is happening? Come on. I don't know what's wrong with the formatting. Okay, this is definitely not correct. Oh, come on. I don't want to be fighting with the formatting, damn it. Yeah, there's something really wrong with the formatting right now. I don't know. I'm not quite sure how did I manage to break this, but it's definitely not okay. Right, so the small killers are exactly the same idea. So small killer, k cores, I keep creating the squares. I mean vector of squares, and then just create it, right? This should all be fine. What I want to do over here, although, is move these things because I don't want to copy them. So they just get moved into setup checkers, which is okay. Right, so now if I call this with the correct constructor, I should get properly initialized puzzle that also has the killer and small killer blocks. I still need to do the pre-computed sum areas. Okay. Well, for now, let's just not do that. Again, the reason why I wanted to have it is because in this example, for example, right, like it's two rows that have this one square overhanging out of it, which means I can immediately say what's the number in this square. But we can definitely start with just singles, right? Like we can start with just looking at rows and blocks. Although, again, that's pretty weak, but yeah, I mean, it is what it is. So yeah, this difficulty 10 puzzle problem like has no chance to be solved by using that, I think, but yeah, we can definitely do something with it later. Or I mean, okay, I can keep the pre-computed sum areas, but I can just initialize it, at least for now, with very simple stuff. I can put in all the rows, all the columns, all the 3x3 squares, and that's it. And I guess for like diagonal Sudoku, I would also put in the diagonals, right? Yeah, something like that. Yeah, let's just initialize it with the basic blocks for now, and then I can kind of, yeah, I can just keep extending it and making the solver more powerful, essentially. Right, so after I have all these, then what I want to do is go over my blocks. No, checks, right, go over my checks, which are my basic blocks. Then for each of them, okay, block checker, okay, I have this thing, right. Yeah, I think I just want to initialize the small killer with the same content. So this would basically be pre-computed sum areas and place back. The sum is always 45. Well, I guess it's sure, whatever, let's do 45 for now. That one need to be changed. And this will be k.lm. Okay, I think this will complain because this is a private thing and I haven't made, yeah, I did not make this class a friend of the block checkers. I mean, okay, I can avoid doing this thing if I just do it whenever I'm creating the checks, right? So yeah, basically over here, so I can also do pre-computed sum areas and place back block. Yeah, that's kind of That's kind of the idea over here. Column, and there should be a row somewhere. Yeah, over here. Right, so here I insert the rows, here I insert the columns, here I insert the 3x3 blocks. Oh shoot, okay. This is an issue. I need to change this to this is I guess explicitly this is diagonal. Right. Then this, oops. Okay. Yeah, and these two things need to go into the pre-completed sum areas as well. Yeah, so just D1 and D2. Oops. And just to avoid the hard-coded 45. Right, so I will just create const block sums. Yeah, and basically these things I need to fill in. 49, 64, right. Okay, that's kind of the limit what we are doing. Okay, so what's the does this work? Not particularly. If I do this, oh yeah, this is misunderstanding what I want to do. Okay, so this way it works. Okay, cool. So 16 is 136, 136. Then 25 is 325, 325. Then 36 is 666. Then 49 is 1225. And 64 is 2080. Okay, 2080. Perfect. Right. So we have this, and this is complaining. Okay, should I just make it a map? Okay, no, still no. Maybe. Yeah, okay, seems to be happy now. Cool. Right, so this I want to use over here. Not over here, damn it. Over here. Block sums and this, right, is size. Okay. So now this should be generalized. Here, and the last one is here, right? Okay, indeed. This is still complaining about stuff. Why are you complaining? No viable overload. Okay, sure. Yes, indeed, this is a const, so now it's complaining about things. Okay, wait, no, just add is const map type. Yes, okay, so this should return the correct thing. And this should not fail because the only sizes that I have are the correct sizes. But I mean, if it fails, it will just throw an exception, and that's perfectly fine in this case. Actually, I wouldn't mind that at all. Right. So okay, so we have. Okay, so we have the precomputed areas, we have the killer blocks, we have the small killer blocks, all initialized. Right. So what's next? Next, I guess I just need to make like a test or something. I guess that would be the best thing to do. Yeah, basically a test case over here. Yeah, so killer Sudoku. Okay. So and now I need to make the grid. Right. And I need to do this manually because there's no other way to do it, I don't think. Right, okay, so I need the killer cage. Okay. So std vector of killer cages, push back killer cage with. Okay, let's just take the simple puzzle. Okay, yeah, let's just try to implement this one. Okay. Right, so the first one is sum 21, and then I have the coordinates, so 0 0. Oh, this will be so tedious. So 0 0 1 0 and 0 1. Okay, that should work. No matching. Ah, yes, okay. dot sum equals dot chords equals or is this C++20 syntax? No, this should work fine. Okay, no, it's still complaining. What are you complaining? Expected curly brace? Oh, yes, because indeed that's a completely valid complaint. It seems to work. Okay. Oh geez, okay, I need a break before I start doing this because this will kill me. So it'll be so tedious just like copying the entire puzzle by hand, and I cannot make mistakes. That's the worst part. Okay, yeah, 5-minute break. See you in 5 minutes. Okay, and I'm back. So let's continue with this craziness. One thing I actually wanted to try. So if I just do kgs.mplaceback, can I just do this? Oh, this will probably not work, but actually, can I just do this? 21 and this. Will that work? No. No matching. They use incomplete type. No, incomplete pack int no value for template arcs. Oh shoot. Right, okay, because it doesn't understand that this is std per. Okay, like at this point I'm making it longer than it was. Okay, so pushback it is. I guess I could do mplace back with this. It will basically use the move constructor. I mean, that's okay. Sure. Okay. Yeah. No, that's fine. I mean, I think pushback should actually use the move constructor anyway, so I don't think it matters. But meh. And plays back. Right. And we continue with this nonsense. Right. So the second one is sum is 6. And the coordinates are 2, 0 and 2, 1. Okay. Then the next one is 10. And it's 3, 0 and 3, 1. The next one is 10 again. A 4, 0 and 4, 1. Then the next one is a 13. And yeah, I mean, the actual order here doesn't really matter. The only thing that matters is I don't screw up the coordinates. 5, 0, 5, 1, then a 12. Okay. 6, 7, 8, right. So this is a 6. Then an 11 that goes into the corner. And I guess... Okay, let's... Before I lose it, let's just save the URL. Okay, so this is a 7, 0, then an 8, 0 and an 8, 1. Okay. Oh, but the sum is 11, not 12. Right. Okay, so I have a 21. Okay, 6, 10, 10, 13. 6, 10, 10, 13, 12, 11. Okay. Then this 9 and this 18 on the next row. Okay, so let's do that. So the 9 is coordinates 1, 1 and oops, and 1, 2. Then the 18. Guess actually I can copy this one. So the 18 is 7, 1, a 7, 2, and then 8, 2. Yes, okay. Oops, what happened? Misclick, right. Okay, okay, now it's okay. Right, so then this 18 over here. Oops. So this is a 0, 0, 1, 2. So 0, 2 and a 0, 3. Okay, and yeah, I mean, this is the one benefit I would get out of doing the UI first. I wouldn't have to do this kind of crap. But I think I really need to have at least one of the puzzles to kind of play with in the code anyway, so meh. Okay, so then 1, 3. Okay, so then these 19, this 19 is 2, 2, 2. Okay, so 2, 2, 2, 3, and 2, 4. Right? Yes. Then the 9. I guess 2 9s in a row. So the 9 is 3, 2, and a 3, 3. The next one is the same, but the next column. I'm just realizing, am I screwing up the times size? Shoot, I'm screwing up the coordinates. They should all be in inverse. Because my x is this, because I keep multiplying it with size. Damn it. Yes, yes. Because then, yeah, the first coordinate tells me the row, and the second coordinate tells me the column. Okay, let's try to fix it. So 0, 0, 0, 2, 1, 2, 0, 3, 1, 3, 0, 4, 1, 4, 0, 5, 1, 5, 0, 6, 1, 6, yes. It's kind of impressive how often I make these kind of mistakes. Alright. Okay, 2, 8, 0, 3, 0, and 3, 1, 2, 4, 2, right. Actually, it's good that I noticed it now and not like after I filled in the entire thing. Okay, so let's just quickly double check. So 2, 3, and 3, 3. So 2 is here and 3 is 0, 1, 2, 3. Okay. And 3, 3. Yes. Okay. So that's now is correct. So the last thing was the 2 9s, then this 15. So it's the row 2, column 0, 1, 2, 3, 4, 5, right? Then row 3, still column 5, and then row 2, but column 6. Okay. Okay. Then this 18 we already have. So going to the next row, it's this 9. Oopsie daisy, I just realized I'm screwing up the sums, so this should be 15. This should, okay, now this should be the 9. I don't know what's happening today, but my concentration is just wavering. Right, so this is row 0, 1, 2, 3, so row 3, column 6. So row 3, column 6, row 3, column 7, and then row 4, column 7. Cool, then just this 6 over here. So the coordinate, so the row is 3 and 4, right? So 3 and 4, oops, and the column is 8 in both cases, right? Okay, then we are over here. So the sum is 3, the coordinates are row 0, 1, 2, 3, 4, and a 0, and a 5 and a 0. Then this one, what was it, 14? Yes, 14. So 14. Okay. Okay, like that. Yeah, so this one is the 5, 2. Okay, so then this 19 going like that. So this is all row 4, but positions 3, 4, 5. So 3, 4, oops, 4, and 5. Oops, what the heck? Right. Oh, come on. The ID is fighting me today really hard. Okay, so the 3, 14, 19, so then the 21 over here, and then we are done with this row. So the 21 is row 4, column 6, then row 5, column 6, and row 6, column 6, right. Okay, then we are on the next row, so this 15. Okay. So the 15 is row 5, column 3, then row 6, column 3, Oops. And row 6, column 2. Well, let's do it in the normal order. Right. So yes, these two and this one. Then the 8. Okay, so the 8, we are still at row 5, column 4, and then row 6, column 4 as well. Okay. Then over here, row... Okay. But first of all, sum is 7. Row 5, column 5, yes, and row 6, column 5 as well. Okay. Then this 20 is still row 5, columns 7 and 8. So 7 and 8. But then row 6, column 8, which is this square. Right. So we have done this row. Now the row 6. Oh, come on. So this is a sum of 14. So row is 6. Column 0, and then 6, 1, and 7, 1. Okay, so we have this, okay, this 13 I need, which is still row 6, but column 7, and row 7, column 7 as well. Perfect. Okay, last couple of things. Okay, so this 18. So this is 7, 0 and 8, 0. And did I see right 8, 1? Yes, 8, 1. And I have the wrong sums. So the last one, 13 was okay. Now this should have been 18. And then we are here on the 12. Okay. Oops. Okay. So 12 is row 7, 2. And row 8, 2 as well. Okay. So over here, this is a 6. Like that, yes. Then the same idea for the next one, which is a 7. Did I see it? No, that's a 9. Okay. So column 4. Next one is a 10 in column 5. Then the next one is a 7 in column 6. And then the 14 at the end. Okay. So this is 7, 8, 8, 7, and 8, 8. Right. Yeah, so 7, 7, 8, yes, and then 8, yeah, okay. Jeez. Okay, so we want the Sudoku basic, then kgs, and then nothing for the last thing, right? Okay, let's just see if this compiles. Right, okay. I kind of forgot about these. Okay, now it compiles at least. Okay. It shouldn't explode or anything. It's not exploding. Good. Right. Okay, so now for the actual work, right? So okay. Several questions now. So where exactly do I put the killer Sudoku propagation? Oh, and I still need... Right, I still need to pre-compute the all the possible distributions of the sums. I mean, for a 9x9, I can just copy it from the internet for now. But I guess I would really prefer to have a thing that would just compute that. I mean, it could just be a file on the side. Like, I don't really... It's basically like generated code. I can kind of do it through constexpr, but I don't have to. I think some of these, where was that? When I was like looking at the solving techniques for the killer Sudokus. Oops. Killer Sudokus, there was an explanation, like a list of all the possible sums. Was it? No, that's not the one. Cage combinations. Right, okay, so this one literally has like all, you know, all the possible lists of things. Yeah, I guess for now. Damn. I do kind of pre-compute this. But how would I do this? Like, it's a vector of things. I mean, it's offset, it starts at 2 basically, right? Then it goes 2, 3, 4, 5, 6, 7, 8, 9, yes. And obviously 9 is odd numbers. And I can definitely Okay, so if I make it as std array, I know exactly how big the array will be. Now the only problem is inside of the array I will need to have this thing. Yeah, I think I will just copy paste this for now. Especially today, like my brain is just not in it. And I'm sure it's possible to make this computed with const expr. I just kind of feel like it's like too much hassle for now. Okay. So where will this live? I think it should live next to the killer block checker. That kind of makes sense. Okay, so let's think about it a little bit. So we always have yeah, okay, so these just always go, these are, it's basically a range of numbers always. There shouldn't be any gaps. Yeah, having gaps would be weird. So I can kind of have an std array. Of what? So I would definitely have an offset, and then I would have the std array of the combinations, and then those okay, this actually isn't that easy even to copy paste. I'm just realizing. Okay, so if I do it the stupidest way possible, it would be std map of the like size to the sum to a vector of possibilities, or the vector of sets of numbers, right? That's kind of the easiest way to do it. So basically vector of vectors. Right, okay, so it's std map const std map unsigned to std map unsigned to std vector of std vector of unsigned sure, sums or something, right? And this entire thing I kind of want to initialize inline. Okay, geez, this will be extremely awkward. Right, so I said it's the first is the size. So size 2 points to a map of the sum, which in this case would be 3, and the vector of vectors Oh jeez, this is absolutely horrific. No, actually... No, okay, so this is... So for the two... Okay. Yes. Vector of 1, 3, yes, okay. Oh god, this is pretty bad. 1, 4. I mean, I guess this is getting formatted in a reasonable way. Okay. I need to... This is just way too much work. Okay, let's try to figure out some way to make this easier. Oh crap, how will I do this? I'm genuinely tempted to just compute this in code because of how horrifically big this is. Like just copy pasting this stuff will take me a long time. And I don't really see a easy way to just make this faster. Like I can do certain things, I can like reformat some of it, but okay, let's think about this. So if I know the size and the sum, I basically want to generate a vector of vectors. Right? So this basically is a very simple backtracking algorithm. I mean, I could just make it runtime and just compute it once at the beginning. Because I mean, I guess technically this is like size to sum to vector of vectors. But the first size is the size of the puzzle. Right, so if I have a Sudoku of 9 by 9, then within that is the size, which is like the number of squares within that, and then the sum and so on. Okay. Okay, I think I will leave this for tomorrow because, yeah, I'm just not feeling like doing this today. My brain is a little bit too fuzzy for this today, and my voice is also kind of dying for whatever reason. I'm not quite sure why. So yeah, I think this will be it for today, even though the stream is a little bit shorter than usual. I think it's long enough and we made reasonable progress. So let's just note down what I still need to do. So, okay, so to do, right. For killer Sudoku specifically, what I need to do is generate a map of sums, which is size of puzzle to size of killer block to sum of killer block to vector of number, right? So that's one thing. Then I need to plug in the killer Sudoku solving techniques into the solver. So they need to go into like a specific place. So let's say, you know, if I deem it that like the intersection should basically be harder than, I don't know, block of size 4 or something, that then it needs to go into that place. Then out of the, okay, let's hide this. No, okay, hide this thing. Only certain, okay, so right, we need a solving technique that limits the possible numbers and possible sets of numbers across the squares inside of the killer cage. So this is the two different directions, right? So one of them is basically if we know that the squares cannot have a 1, obviously none of the options for getting the sum that need a 1 are possible. And the other way around is basically, so we will need to keep track of the which of the sums are still possible. That's definitely true. We will need okay, yes, the other way around. So if we know that it's basically the, okay, that basically goes back to the intersection stuff. So if we know that for sure we need 1, for example, in the cage, then obviously that will be claimed by the puzzle. And the things we have already thought about are the solving and mostly actually implemented are the solving techniques based on the 45 sum, which, yeah, we still don't have the big one that actually takes many blocks and looks at like the protruding squares that are either missing or overlapping. But at least we have the one that works on top of one block. Okay. So yeah, that's all stuff for tomorrow. So yeah, thanks for watching, and that will be it for me for today. And I will be back tomorrow again, 2:30 p.m. as usual. And see you then, hopefully. Have a nice day.